Next, I have Balaji. Balaji uh, founded Enida System, which is a company which again has a footprint in the US as well as here in India. So, we have so far looked at the money. We have looked at building the ecosystem. We have looked at building up your own company. Now let's shift the focus to the industry. That what are some of the industry issues and what can be done to address that?
Thanks, Pradeep. Good afternoon, everybody. I'm going to take a few of the points made by Hemant, probably in a more detailed fashion from the focus required around the design companies, actually. So just to begin the presentation, I'm just going to give a overview of the Enida. So basically, we have been around for the last 1.5 years. Again, full R&D completely out of India, out in Hyderabad, and our business development in Santa Clara. And I tend to disagree about the points generally made in most of the discussion forums that we India are fundamentally lacking on the application of the technology and coming up with game-changing scenarios. Definitely at Enida, we're looking at something for the first time in the industry, a brand new architecture. So as you can see, we have a bunch of patents to cover around our core technology. And we're still in stealth mode, so obviously I cannot share a whole lot of information except for I can say the foundation technology is already working in our lab with the prototyping software and the system. And we are currently executing on our SOC. So let me just start with a global view of the semiconductor ecosystem. So currently, on an average per year, we are actually seeing only around 15 startups receiving Series A funding. And compare this with the number of IPOs and mergers per year. This is around 50. So this is definitely not a good sign. We're going to hit a wall pretty soon. And back in 2000, around the dot-com rush time, basically, to just get a prototype product working, specifically in the silicon space, it used to take around $10 million. And now, just to get the first sample out for a semiconductor company, it's close to $30 million. And as Hemant mentioned, it will be $100 to $150 million before we really get to break even for a product company. So we can see there's a big increase in the R&D investment over the last decade. Now the third thing, most of you who are hardcore technologists, you already know the complexities involved going from technology generation to generation. So the R&D costs are increasing at a tremendous rate. So just to look at a product, what it takes to build and the cost involved to develop a product, especially for a startup, it is a lot more critical. So it's pretty much like a iceberg as you see on this picture. So most of the weight is under the water trying to sink the iceberg. And this is all your non-differentiating work. Basically, this is your engineering infrastructure, just implementing a chip, the verification of the chip, and all the other non-differentiating IP you need to put together to get a SOC product out nowadays. So more than 80% of the capital is just gone into these non-differentiating pieces of R&D. So the core IP or the technology that the company is really working on is probably like going to cost only 20% of the capital. But the reality is still we need to spend quite a bit of amount to get a product to reality. So what kind of differentiators are needed? By the way, this is a discussion happening very well even back in the Valley now. I'm going to talk about some of the GSA initiatives in the next slide, but we definitely want to shrink the size of the iceberg so that at least it can stay afloat as longer as possible. So definitely we are talking about a lean and efficient R&D structure. Having a low-cost geography based R&D is definitely going to be a plus point from China, India, and some of these other countries. And as I discussed previously, so the focus of the startup needs to be really around the core and the differentiating technology. And we need to reduce the cost for all the non-differentiating R&D pieces. How do we do that? I'm going to get to that in the later slides. And then reduce your overall engineering cost till you achieve a prototype. This is where most of the VCs are going to look at it and say, this is not my cup of tea, as well, let me just move on. That's the reason why you are seeing the dwindling scenario for semiconductor startups. And then the faster time to break even. If you can plan about this right from day one, especially with the SOC technology going right now, how you can penetrate your primary market and quickly expand into the adjacent markets. This thought needs to be there from day one so that you can really get into higher volumes and bigger revenues and kind of make a justification for the investment required. So some of these issues are already being discussed at various levels, and GSA back in the Valley is putting up a few initiatives. So they are working on a model called Capital Light, basically. So there is a working group. They have been debating about this for the last 6 months. They're hoping to have at least a couple of companies funded in this model by Q2 of this year. I mean, at a high level, basically, there are a few models. Most of these are like common sense. How to defer your costs to get your prototype part out. So obviously, you don't want to redesign all of the IP required, which is non-differentiating. So if we can just source this IP against some sort of equity, so equity for IP model, or you can even have deferred payments and along with the royalty and the license fee itself coming at various time points, basically from the project maturity or from the company maturity, or even additional points where the bigger company actually which can give this IP or the system around the IP and even try to leverage some of these costs towards their P&L so that it will be more attractive to them. So these are some of the things that are already being worked out by GSA, and I'm really looking forward to see a few of the companies funded in this model this year. This is going to encourage a lot more semiconductor startups around the globe. So having talked about these issues basically and the general thought process of the semiconductor startups, how to reduce the cost to get to break even and all. So what is it that we are doing at Eneda? This is my latest experience. So I can talk about more about some of the ideas we are already implementing at Eneda. So as we speak, basically, we have the full R&D team out of India. So those are the people who are still thinking that we don't have the system architects or we cannot design products completely out of India. I'm talking about completely the other way. Actually, we are talking about the full conceptualization, architecture, design, verification, and even going into the chip backend and taking it to production completely from India. So we are definitely very upbeat that we can do that. And the business development still stays in US, given that we are building products for the global companies. And this is one place where most of the innovating companies are still out of US. Some of them in Japan or Europe, wherever basically. But definitely, India is still not there for a major innovation semiconductor product. They're more of a fast adapter. So definitely, we need to continue having business development from USA. And then talking about the world-class R&D team in India, how do you really build this kind of team? Why should the people leave their cozy setups in MNCs and with all their packages and career profiles, everything to get out for the startup? So the key point, I mean, I listed a few of the things. Maybe the couple of key points I would like to highlight is, one, do they really trust the leadership team that they can really take it a long way and take it to a path of success? Then the second piece, basically, most of these people have a lot of passion for doing indigenous R&D from India. Definitely, this is what I think a lot of people are excited about, but there are not too many avenues. So at Eneda, we are able to get the best-in-class talent based on these factors. And the other piece, given that we don't have a fully understanding VC ecosystem in India, especially for semiconductors, we depended mostly on the private funding from the individual investors as well as the management team so that we can actually continue our vision without worrying too much with respect to the financial aspects till we get to the prototyping state. And the last piece, which is the most important one, is the ecosystem partner companies for non-differentiating IP. So we are working with a couple of companies closely, especially for inducting very skilled freshers to come in for the bottom 10 to 20% of the pyramid from the Veda IIT, which has great success already in Hyderabad. And then another ecosystem company by name Octonix to really work out on the non-differentiating IP. We need so many of the peripheral controllers, a lot of these SoC building blocks, which really are not going to be the differentiating piece for us in a ecosystem where the other company can take advantage of that IP for their business. It would be a better situation, and we are able to do that with our ecosystem here. And some of the other pieces, these are very similar to the GSA initiatives. I would say we have probably around 60 to 70% success here, especially with respect to our IP and EDA vendors. So we were able to get the required support to defer some of these costs, especially for prototyping, so that like we can raise more capital when we start seeing the real product out. So definitely we have a good success. So whatever GSA is trying, kind of Ineda is already doing for the last 1.5 years. So definitely would like to see more companies doing this. And obviously, right from day one, we were ready to take the technology into the adjacent markets as well. As we discussed, unless until we see hundreds of millions of dollars revenue, or even going to billions at some point, it doesn't make sense to raise $100 to $200 million capital for a semiconductor startup. So definitely, we are thinking about this right from day one, right from the concept architecture state. So talking about the Ineda experience, and I mean, definitely we are lucky to have an ecosystem that supported us from back in Hyderabad. But what more, if I were to not have that kind of ecosystem, what is the thing that I'm looking from India, whether it is a government sponsored or a private consortium basis? Basically, if there is an infrastructure that is available for wannabe entrepreneurs to just go in and have the bootstrap support. This is to just have your all the compute, IT, the office space, most of your standard IP, EDA tools, everything available there, so that we can directly focus on the product and worry about raising the required money and some of the business development aspects later in the game. So this is what actually, at least to my knowledge, I am seeing some of the other countries are already doing. And even though they are lacking the design talent as much as India, especially I'm seeing this is going to happen now, probably both in Russia and Brazil. But I think Indian government is still not enabling this, as well as either from the private consortium basis. I'm hoping somebody is going to take this step sooner than later. Then the other piece, the obvious one, is definitely the local funds for the startups, whether it is VC funds or the government-sponsored innovation funds. Whenever we talk to our vendors, we keep hearing that the similar kind of startups back in China, they keep getting all sorts of support from the government, and they are ready to spend more. And the comparison is always with China, and we are struggling on that aspect. To get a favorable deal, for example, to just push out some of the costs, it's not an easy thing. So definitely I'm hoping in the next few years, we'll see some of this betterment from either the government or from the private industry.